Hello and welcome. My name is Jennifer Gates, Field Services Director for the California Preservation Foundation. The California Preservation Foundation is a membership-based, not-for-profit organization whose mission is to provide statewide leadership in education and advocacy to ensure protection of historic resources in California. We want to thank you for joining the fourth webinar of the California Historic Building Code series entitled Structural Requirements and Archaic Materials, and encourage you to become a member of CPF and enjoy the benefits and educational discounts. Information on membership can be found on our website. The format for today's webinar will include a presentation followed by time for questions and answers. There is a toolbar on the right side of your screen. If you have a question at any time during the presentation, please type it in the box and we will hold the question until the end for the presenter to answer. You will be muted throughout the presentation. To hide or unhide this toolbar, click on the orange arrow. Please adjust your volume on your computer or phone. Today's presentation will be by Stephen Harris. Stephen Harris has practiced structural engineering for over 27 years. He is a graduate of the University of California at Davis and a registered structural engineer. His experience includes design of new structures, seismic strengthening of existing structures, and design of pile foundation systems. Mr. Harris's noteworthy projects include seismic upgrades of numerous historic buildings, including the San Francisco War Memorial Veterans Building, the California State Library and Courts Building, the Sacramento Memorial Auditorium, and South San Francisco City Hall. His portfolio also includes design of the 29-story 199 Fremont office building in San Francisco, the new County Government Center in San Luis Obispo, as well as the seismic upgrade and expansion of the J. Paul Leonard and Suture Library at San Francisco State University. Thank you for joining us today, Stephen.
Thank you, Jennifer. So today we're going to talk about the structural portion of the California Historical Building Code. We're going to talk about chapters 8-7 and 8-8 of the State Historic Building Code. Each of these sections talks about the purpose and intent of the code, points to some other documents, and provides some basic provisions for how to approach historic structures where more information is not available in other places. We will be talking about the 2010 edition, which is the current edition. These are not very long documents. I think only about 6 pages total between the two of them, so we can talk about them in a fair amount of detail in each of the various provisions. We will go into a little bit more detail regarding the lateral load regulations compared to some of the other provisions. We'll talk about Chapter 34 of the regular building code as well as the International Existing Buildings Code and Asce 41, which is a document put out by the American Society of Civil Engineers as the national standard for rehabilitation of existing structures. Chapter 34, of course, is applicable to all existing structures. The IEBC, the International Existing Buildings Code, is not actually part of the California Building Code, but the CBC gets a little bit sneaky in that they reference the IEBC in Section 3401.8. Also, we do have a California version of the International Existing Buildings Code, the CEBC, but that pertains to only Appendix Chapter A1 of the IEBC. Now, Asce 41 that I talked about a minute ago is specifically allowed as an alternative approach in the IEBC, and we'll talk more about Asce 41 later. So here's an outline of what we're going to be discussing following the introduction here. We'll go through Chapter 8-7, which is the structural regulations. Again, talking about the purpose and the intent, talking about structural survey, which is essentially an existing condition survey. Talk a little bit about non-historical additions and alterations, structural regulations, which are essentially everything but seismic, and the lateral load, which is really just the seismic part. Following that, we'll talk about Chapter 8-8, which is the archaic materials portion. Again, this discusses what its purpose and scope is. It talks about what types of materials are around in archaic structures, what those materials might be. Specific conditions are provided for individual materials, masonry, wood, adobe, concrete, etc. We'll talk about those each in turn. I'll also talk about the table at the end of that chapter, which gives strength values for existing materials, and then finish with a brief summary. Structural regulations. The purpose of these structural regulations is to provide an alternative to be used for historic buildings. The code references specifically qualified historic buildings and indicates that you can't just use this if you think it's appropriate. You need to get approval from the enforcing agency. The idea behind everything, of course, is to encourage preservation, to provide a minimum level of performance that's appropriate, and to prevent collapse and life-threatening injury. That's the same performance goal that exists in the main building code for regular structures. The idea, because this code is only a few pages long, is to be applied in conjunction with the regular code as well as in conjunction with other documents. In general, the idea here is that we want to provide a level of safety, and that level of safety for critical facilities should not be reduced. In other words, if you have something like a hospital or a police station or something that's also a historic structure, you're really not intended to be using reduced values for those elements. You really should be using the provisions of the regular building code. That said, it also specifically says that you can do a voluntary upgrade, particularly for seismic purposes, without any regard to specific provisions. Structural survey is what they call essentially both reviewing drawings and also reviewing the conditions in the field. With any existing building, and particularly with a historic building, the survey is critically important in order to understand what you actually have. You may have a great set of documents, and you may have had some changes that have occurred to the building over time, or the documents themselves may not be very good, and you may have to spend quite a bit of time in the field to document yourself what's actually there. There's a particular requirement with regard to anchorage of veneers. The CHBC in the structural sections really spends quite a bit of time on veneers relative to other things because they are so critical in terms of safety, not only for occupants, but for those outside the building. If you're going to be adding or altering non-historical portions of the building that are structurally separate, then you would just be using the regular building code there. The existing structure is not permitted to support additions unless the existing structure is strengthened. This is actually a little bit more restrictive than Chapter 34 and the IEBC, which both give a little bit of leeway, 5% additional for gravity and 10% for lateral load. But since the State Historic Building Code is an alternate provision, you're always permitted to use those normal code provisions, which would allow you those small increases even for historic buildings. The structural regulations here are essentially everything but lateral load. Everything but seismic. There is a specific provision that says with regard to gravity loads, you're allowed to consider that the structure is acceptable if you don't see any distress and you do see a complete load path. That is, the fact that the building has been around for a number of years and has been successfully resisting gravity loads for all that time. If there's no change in the loads, then it's permitted to consider that that's acceptable. You do have to evaluate for wind and seismic, as indicated in the subsequent sections. Wind loads are allowed to be reduced. You only have to use 3/4 of that specified in the regular code. But you do have to correct something if you see that it's unsafe. there's an interesting provision here that says if you are able to improve the performance, that is to reduce damage, particularly with regard to wind and seismic loads, without impacting the historic fabric, then you're recommended to do that. Of course, it's not much of a code provision, but it is a suggestion that wherever possible, you should improve the performance because that will aid in the preservation of the structure. The lateral load regulations are essentially the seismic regulations. We'll spend quite a bit of time on this relative to some of the other provisions. First of all, the CHBC says you're allowed to use the R factors, that is the strength reduction factors that are applicable in the regular code. The thing is that they're not usually applicable because they all come with special detailing requirements attached, and it's very rare that in a historic structure you're actually going to see things that comply with those detailing requirements. Again, like the wind requirements, you're allowed to use 75% of the loads that would be specified in the regular code. If you look at the base shear equation here, I've circled the 75% element and also indicated where the R, the response modification coefficient, goes in one of the base shear formulas that may be applicable to the building. In addition to the 75%, you are also allowed to ignore near fault effects. The ground motion indicated in the formula there is S sub ds is larger as you get very close to faults, and you're permitted to ignore that increase except in occupancy category 4, which is unlikely, I suppose, for a historic building. If you're putting a new system in to help out the building because the existing lateral system is not adequate, then you can use the R factor for the new system only if that new system resists 75% of the total load and the existing system only resists a quarter of the load. In order for this to occur, the new system has to be 3 times stiffer than the existing system, and this is not at always an easy thing to do. If you have an unreinforced masonry building, then you're required to simply jump out of these requirements and comply with the California Existing Buildings Code, Appendix Chapter A1. Again, that's the only portion of the IEBC that's actually part of the CBC. And that's a specific set of provisions that are intended only for the use of unreinforced masonry buildings. The code now gives an alternative to consider the ultimate capacity of materials. That is, what's going to happen in their eventual state as they get pushed farther and farther. This is specified rather generically, but they do indicate that you can do this only when you allow for the appropriate ductility and reserve strength that really exists in those materials. This is a nice provision. It's more specifically addressed in Asce 41 that we'll talk about in a little bit. And the point here is that they make a discussion about seismic demand and not just seismic forces. So they're talking about movements which are really critical as opposed to just forces. Parapets are addressed specifically because they are potentially quite a hazard for passersby, and you jump out of the CHBC and just comply with the regular code with regard to parapets. Veneers you're required to evaluate, but there is not a specific requirement except what exists in the regular code. Similarly for partitions and for ceilings. Alternative provisions for lateral loading exist in Chapter 34, where there are requirements for modifications which are permitted within listed thresholds. IEBC, as I've discussed before, is a great resource. Depending on the level of work, there may be a full or partial upgrade necessary using the IEBC. The full upgrade that they discuss is essentially equivalent to the regular code. The partial upgrade is 3/4 of the design forces. This is the same as the CHBC, so it really is pointing you in the same direction. ASCE 41, this national standard document, is permitted explicitly as an alternative way of complying with the IEBC. This document, called Seismic Rehabilitation for Existing Buildings, is a national standard. It's been around for quite a few years now, and a new version in 2013 is just about to come out. It has a lot of great material on strengths, far in excess of what you're going to find in the chapter 8-8 that we'll talk about in a little bit. It's really the best and most appropriate approach for seismic analysis and upgrade of any existing building, particularly a historic building. The reason is because this is a displacement-based approach rather than a force-based approach, and it encourages nonlinear analysis. This, of course, is going to take more effort in the analysis and often requires a peer review, but it really allows the specific consideration of actually how these archaic materials behave, and provides a lot of guidelines as to the appropriate levels of deformation that are acceptable. These guidelines are based on state-of-the-art research, which is continuing, and we do have a lot of great information about archaic materials, as well as not quite so archaic but still older materials. This allows the best consideration of the capabilities of the existing building. As a result, it's more historically sensitive and results in lower construction costs, if higher engineering costs. Here's a little example of the lateral load regulations, not through ASCE 41, but just to run through a couple of numbers so that you can understand how these requirements might work. Here's a picture of a lovely historic building. You can tell that it is because it says so. This is a reinforced masonry building, so it would not be required to be using Appendix Chapter A1 of the IEBC. The ground motion is a fairly typical ground motion, 1G for S sub ds, and the seismic weight of the building, 320 kips. Now, because we're told to use the R values for new construction, we have to use the ordinary reinforced masonry R value, which is essentially the lowest value that you see in the R factor table. As we calculate the wall shear across the front of this building, right where it says historic building, we get to use 3/4 per the SHBC of the weight times 1G divided by that R value of 2. So that's 120 kips shear across the front of the building. There are 4 36-inch long wall sections. We'll presume that they all take the same amount of load, even though as it's drawn it wouldn't quite be true. So there's almost 1,100 square inches of masonry there. We can calculate then the stress in that masonry of 109 psi. And that's greater than 62 psi, which the code says you can use in the existing masonry. So therefore you would need to add a concrete wall backup behind that existing wall. Again, if you're using ASCE 41 or some more high-tech approach, you may be able to get a little bit benefit here. Using this basic approach, there's no alternative but to strengthen. Now, if you want to use the R value for the new material, then you would have to have something 3 times stiffer than the existing material. If we made the concrete the same thickness as the masonry, that is the new concrete that's backing up the masonry is the same thickness, it would be about 1.5 times stiffer than that masonry. So it's less than 3 times stiffer, and we're stuck with that very large load that's due to the R value of 2, because we're only half as stiff as we would need to be in order to use R equals 5. These arbitrary R values are one of the main reasons that it makes so much more sense to be using ASCE 41. All right, enough math. Let's talk about the Archaic Materials chapter, which is chapter 8-8. The purpose of this chapter is slightly different than the purpose of the previous chapter. The idea is that it provides regulations for materials and for methods of construction, again only for qualified historic buildings. It allows for the use of materials that are not codified otherwise in the regular code. These provisions apply to any material that's part of the historic building fabric. It allows the historic materials to remain in place or to be reinstalled if they're removed and to be replaced in kind. There are limitations on replacing in kind. It's kind of a dangerous thing to do. For example, if you have an unreinforced masonry wall and a portion of it is removed, to replace it as an unreinforced masonry wall is kind of a questionable thing to do, but it is within limitations. It is permitted by this chapter. The general approach is that they have tabulated values, but it is recommended to test materials wherever possible. The bottom line here is that there are values in the table. They recommend that you do testing, but the values that you actually use in the design are really the responsibility of the designer and subject to approval by the enforcing agency. You're allowed to continue to use non-conforming archaic materials, provided that there is no public health or life safety hazard, and of course where the agency approves. It's required that you evaluate the condition of existing materials. When you look at the concrete in this picture here, you can see the deterioration of concrete is a pretty important thing, and it applies also to masonry, adobe, steel, essentially any material. You need to assess the existing condition for the existing loads and to see how these various materials are addressed in the subsequent sections. In masonry, which applies to both reinforced and unreinforced masonry, you're permitted specifically to use a shear value of 9 pounds per square inch without doing any testing. This is a value that's a fair amount lower than in the CHBC, I'm sorry, my slide says CHBC, the CEBC Appendix Chapter A1. But it is recommended that you do testing nonetheless. It specifically indicates that if you have stone with brick backing, you can treat it as solid brick within certain limitations. The code also allows you to repair or infill existing walls as they are currently built, but where walls are completely reconstructed, they must conform to the current code. This harkens back to the requirement previously that you are allowed to use archaic materials, but it does say here that if you are reconstructing a wall completely, then it must conform to the regular code. Adobe is addressed in this chapter and really not anywhere else. That is unburned clay masonry. Although there's not a whole lot of information about adobe, this is really the best information about adobe that exists anywhere. They make specific point about deterioration. Clearly, in adobe, both the material itself as well as the mortar are quite susceptible to deterioration due to water infiltration in particular. There are height to thickness ratios for walls that are specified. For single story or bottom story walls, a ratio of 6, and for upper stories, a ratio of 5. These are some pretty stout walls, but that is typically what you see in adobe structures. There are specific requirements then for bond beams at floor and roof levels, that is reinforced masonry elements at the floor and roof levels. Interestingly, they indicate an ultimate shear of 12 psi permitted in adobe, which is actually larger than the value that they permit for regular unreinforced masonry. Not quite sure why that's the case. There are quite a bit of strength values provided in the tables for wood. They do recommend that you investigate fastener details and spacing before using those tables. There are allowable stresses. You're permitted to use the values that are consistent with the codes that were applicable at the time of construction. This is pretty important because the wood was better when many of these older buildings were built, and the older codes actually allow you to use higher stresses than exist for current wood. Square nails or cut nails are stronger than new nails, and you're allowed to use more load in them. Wood dowels and mortise and tenon, which are almost never used anymore, but they do exist in some historic buildings, are permitted to be used provided that they remain in good condition. Existing concrete may remain in place regardless of reinforcing or detailing. It's certainly reasonable if you're going to permit unreinforced masonry, you ought to be able to have unreinforced concrete. It's certainly better. That said, details must be evaluated for strength and behavior. Even if you're using the State Historic Building Code and not using Asce 41, Asce 41 Chapter 6 is still a great resource for strength data. Concrete strength is listed by time, that is time built, and also where it exists in the building. For example, time frame 1900 to 1919, 1920 to 49, etc. For all these various things, footings, beams, slabs. This is so much more detail than you'll see anywhere else, and Asce 41 Chapter 6 has this. There's also information in Asce 41 Chapter 6 discussing reinforcing steel. Again, quite a bit of detail based on year constructed and what grades were available at that time. Steel and iron, not reinforcing steel, but structural steel. Most of the chapter here, 8-809, really concerns itself with wrought iron and cast iron as opposed to structural steel. And they essentially say that you can leave it in place and continue it, but you do need to have a look at the uplift capacity. There's very commonly the column bases for wrought iron or cast iron are not nearly as well addressed as those in structural steel, and they make a particular point of that. They say to assign working stress based on the time of construction, and again, you can look at Asce 41 and this time in Chapter 5 for more information. Even if you're not using Asce 1 for your analysis, please look at these tables because they give you a lot of great information with regard to the tensile strength and the yield strength that was available during different periods. Hollow clay tile, this section is a little different than what you see where the discussions are for other materials. The discussion about hollow clay tile really is more of a warning than anything else. It says, consider the poor performance of hollow clay tile, strengthen it as appropriate, maintain support for gravity loads, and specifically they indicate to protect exits and stairways. You can see in the photograph here that when clay tile is damaged, it tends to fall away, and that can create problems in terms of exiting. This really is the only material where you get basically these warnings as opposed to how to use the material. Veneers are very common in historic buildings. It's recommended in Chapter 8-8 to investigate that the anchorage is suitable and that the anchors have not deteriorated. It's required to provide supplemental anchorage as required either due to inadequate anchorage or due to deteriorated anchorage. Glass and glazing, this section is really not about glass in general, but about glass subject to human impact, where you would normally be required to use tempered glass. There are some provisions here that allow you to leave historic glass panels in place, either by providing additional backup panels, protective film, or some sort of guard systems that will protect against human impact. Strength values are listed in the back of Chapter 8. Chapter E8-8A provides strength values for existing materials. It's essentially a copy of the table that's in the CEBC table A1D. It addresses horizontal wood diaphragms of various types, straight sheathing, diagonal sheathing, both for roofs and floors, and roofs with roofing on or not. It addresses cross walls, which are a specific element that pertain to the analysis methods recommended in CEBC A1 with regard to unreinforced masonry buildings. There are discussions about existing footings and about Douglas fir wood. Reinforcing steel and structural steel, they just give you one number each, essentially. Compare that to what was provided in Asce 41 in those tables that go on and on for different years. I only reproduced about half of the information that was available in that document. You compare that to these single values in the Chapter 8-8. It looks kind of pathetic. There's another table, table E8-8B, which is strength values for new materials used in concert with existing materials. Again, this is a copy of a table from the CEBC. This one, table A1-E, provides values for horizontal wood diaphragms with plywood overlays, that is where you're strengthening an existing diaphragm with new material. Also for new shear walls and cross walls. Tension bolts and shear bolts, these are again elements that are really applicable to the anchorage of unreinforced masonry buildings, the walls to the roof and floor diaphragms. So in summary, the structural regulations provide an outline for the intent of protecting buildings. The gravity loads are deemed acceptable as long as they're not increasing and as long as things are have remained in good condition. Lateral loads, both for wind and seismic, are 3/4 of that in the current code. Alternative provisions in using Asce 41 may be more appropriate. The archaic materials, allowable strength is provided for some materials, again not nearly as specific as those in Asce 41. It's highly recommended to do investigation and testing, and there are some warnings for materials such as hollow clay tile. And that is our presentation. We will be pleased to discuss or answer any comments, any questions.
So at this time, if you have any questions, please type them in to the box, and we will ask Stephen those questions for you. I'll get the ball rolling, I think. I had a question in regards to the windows and the glass.
Mm-hmm.
And so if you are, I'm just thinking back to the days when I was in planning and working with our building department, that a lot of times we did have questions, especially in the bathrooms with the windows, the existing windows in the bathrooms, and what is appropriate for those windows specifically when we're doing some renovation in the bathroom. So if it's the question, I guess, is if it's an existing window, then you can use like the film or another panel.
That is specifically allowed to use any of those three approaches. Either an additional panel, for example, a clear panel behind a stained glass panel, or a protective plastic film, or some sort of a guard that prevents the human impact.
And if you were to replace in kind, so a same size, shape, everything within the existing window opening, that window would not be allowed to use that protective measure?
No, I think, I mean, there is a general provision that allows you to replace materials in kind, and as long as that's considered historically appropriate, then I think that you would be permitted to take the same approach, whether it's a replaced or a existing material.
Okay. Are there other questions from the audience? Okay, here we go. Do you have any particular experience with the modification of entries or openings that supports ADA required modifications that are sensitive to the historic character defining elements?
Can you repeat that question again?
Sure.
I'm sorry.
Do you have any particular experience with modifications to entries or openings that support ADA requirements that are sensitive to the historic character defining elements?
I guess I don't really understand the question with regard to the sensitivity. The question is how do you make a structural opening in an existing wall in a way that is sensitive? Is this really separate from the ADA issue? It's just basically that you have a new opening, and how is it accomplished in an appropriate manner?
This one, widening existing openings.
Okay, widening existing openings. I'm trying to think. It seems to me that that we have addressed that issue, particularly on the State Library and Courts building, where we had hollow clay tile partitions that had doors in them, and in some cases those doors were required to be widened. I don't recall whether it was for accessibility or for some other reason, but in those cases it's difficult to be sensitive on both sides of the wall. What we did in the State Library and Courts building was to provide a backup element on the less sensitive side of the wall that was a piece of structural steel in order to support the new edge of opening. Particularly with regard to clay tile, it's difficult to deal with that material. With regard to unreinforced masonry, generally I would recommend constructing the new edge of opening using some sort of a reinforced concrete or reinforced masonry element. We've done that before as well in the case where there is a stucco parge or something over the face, so that the new element that forms the new edge of the opening is a more structurally appropriate element. I hope those were useful answers.
The next question, are you able to judge from experience which code to use, or do you run preliminary calculations under different codes?
Most of the time we would rely upon our experience to make the choice. It is almost a standard approach that we would expect to be using Asce 41 in almost all cases. In only the simplest cases would we be using the 3/4 of the current code type approach that's permitted in the historic building code. And of course, if we have an unreinforced masonry building that complies with the construction indicated in chapter in the IEBC Appendix Chapter A1, then we would use those specific provisions. But almost all the time we would gravitate towards Asce 41 as a starting point.
Okay. Are there other questions from the audience? Stephen, do you have any additional thoughts or experiences you want to share?
I suppose not.
Okay.
I suppose not. No, thank you.
All right.
We got through this a little more quickly than we did in the run-through, strangely enough. Maybe I was talking faster.
We have one more. We have one more question. Are there alternative values for soil conditions, or do you use standard ones?
What we would normally do is to request testing of the soils by a geotechnical engineer. In almost all cases, we would try that approach first. There are values in the regular building code for existing soils, or for any soil, that are very conservative. And when you're talking about something that's small or very simple, you can rely upon those basic conservative values. But for a project of any significance, I would recommend bringing on board a geotechnical engineer, have them do borings and get some recommendations for appropriate bearing values.
All right, I have another question in regards to the investigations.
Mm-hmm.
What are different types of investigations that are possible for if you don't know if your masonry building is reinforced or not?
Oh, okay. First of all, it's almost always possible to tell just by walking by and looking. There are particular telltales of unreinforced masonry buildings that an experienced engineer will recognize and know immediately. The presence of header courses, arch elements over windows, the proportions of windows versus supporting piers. These sorts of things are real telltales that you can almost always use to determine that if there's some lack of clarity, then you can always use a magnetic reinforcing locator, which is a very commonly used device, or ground penetrating radar to scan the walls and to look for reinforcing.
All right. All right, I don't see any additional questions. So I wanted to thank you all for joining us today. And later today, you will receive an email with a link to a survey. Oh, quick question.
Okay.
Just jumped in. Where can Asce 41 be obtained?
From Asce directly.
On their website?
They will sell it to you. Yeah, on Asce's website, they'll sell it to you.
Another question. Have you had trouble in San Francisco with building officials accepting the Asce calculations?
No, it's quite commonly done. They will generally require a structural design review, also known as a peer review, when you want to use that approach. We are currently working on the Veterans Building downtown San Francisco, and which is on our cover slide here. We are using Asce 41 for that, and we have a structural design review, and it will be permitted through San Francisco DBI. I've also served on the structural design review committee for a number of other buildings that have used Asce 41, and generally DBI will insist upon that review when you want to take that alternative approach.
Do they, the next question in response to that is, do they hire another engineering firm to do that peer review?
The project sponsor hires the firm.
Okay. And another question. Can you discuss the structural values of lath and plaster?
Well, interesting. There there are some values available in a newly published document by FEMA, I think, if I recall. It's called FEMA P807, and that document was recently produced for essentially for the city of San Francisco in their assessment of what to do about soft story apartment buildings. And therein, the softness of the bottom story is really a function of the fact that there are so many lath and plaster partitions in the upper stories that they create a lot of additional strength and stiffness in the upper stories. And so that document provides some great information on the existing strength and stiffness of those partitions. I should say that it really can only be used for that purpose, that is, where that strength and stiffness is not necessarily your friend but your enemy. It's not really appropriate to use those values in order to show adequate capacity of a building that has no other system. I suppose you might be able to get something like that through the city and through a review committee, but it's questionable. Those materials do have strength and stiffness, but I've never seen anyone count on it as a primary resisting element.
Okay. I will give them a few more seconds if anyone has any more questions. And just let you know that there is going to be an email after this presentation with the link to the survey today, and we would appreciate any feedback on this webinar as well as recommendations for future topics. And not seeing any more questions, I hope that you all have a good rest of the afternoon, and thank you again, Stephen, for your presentation today.
You're welcome. Bye-bye.
All right. Thank you.